Alright, so this lesson is for FOM 11, Chapter 7, Section 4, and hopefully you got a chance to watch the video called FOM 11, Chapter 7, Section 4, Part A. Okay, so if you watch that prior to this, then this will make a lot more sense. So what we're going to do is this here: consider the quadratic function y equals x squared plus 7x plus 12. Write it in factored form and graph it by hand. Well, one of the things that you can do, oh, hold on a second. Okay, so one of the things you can do actually is, let me hide that, and notice that we have, actually let me just blow it up. We have an a value of 1, okay? So again, if you had watched the previous video to this, part A, you'll notice that this has a 1. And so one of the strategies that we talked about was, okay, so we draw a little x, what two numbers add to 7, right, my b value, and then multiply to 12. And hopefully you just focus on the 12. How many different ways can you multiply to 12? So go through all the ways you can do that, and hopefully you realize it's 3 and 4. So 3 times 4 will give you 12, and then 3 plus 4, right, will give you 7. Now, what we can do is we can factor this. So it's y equals x positive 3, right? That's my positive 3, and then x positive 4. Now, in our previous chapter 7, section 3, as soon as you have in factored form, what you can do is you can find what's called the zeros or the x-intercepts. If you just focus on x plus 3, we can go x plus 3, and we set it equal to 0. You do a little bit of algebra, you would know that x is equal to negative 3. Okay? We do the exact same thing with x plus 4. We set that equal to 0, and do a little bit of algebra, and that would be negative 4. Now these two values are actually kind of handy. We know that it's a parabola, looks like a u or an n, depending on what a was, right? In our previous lessons, a tells you, right, it happens to be positive 1. Well, positive, what that means is the parabola opens up, okay? So it looks sort of like the motion of my pen. Now, not only does it travel up, but it crosses the x-axis at negative 3, which I'm going to plot right here, and negative 4. Okay, so I know that's a little hard to see, so let me just zoom in a little bit. Okay, so negative 3, negative 4, it's a parabola that, and I apologize, my handwriting is like terrible here, but it's something like that. Okay, now I also have Desmos opened up here so you can sort of see that I'm kind of close. I mean, my drawing is never going to be as good as a computer, but y equals, let me zoom back out. What was it? Y equals 1x squared plus 7x plus 12. Oh yeah, look at that. So look at how it crosses at a negative 4 and negative 3. Yeah. And we have a minimum here, okay? You can sort of see it's at a negative 3.5, and my minimum is negative 0.25. And sort of, you know, close to my drawing. Yes, the Desmos will always be much, much better. Okay? So, what we're going to do is we're going to move on to our next equation. Oh, it says here, sketch the graph, state the domain and range. Okay, well, is my a value 1 now? The answer is no. But we can sort of try to see if it could be 1 by what's called factoring, right? Y equals negative 2x squared minus 14x minus 12. If your a value isn't 1, the first strategy you should always try to do is, hey, can I factor out a negative 2? Can I factor out a negative 2 from each one of these values, okay? And when I say factor, what I really mean is divide. Okay? What I mean is divide. So let's try to factor this. Y equals, if I were to factor negative 2 out, what am I left with? Well, negative 2 divided by negative 2, oh, look at that. 1 x squared, right? Negative 2 divided by negative 2. Negative 14 divided by negative 2, oh, positive 7x. And then negative 12 divided by negative 2, that is positive 6. Now, I'm going to focus on my a value. It's 1. Life is good. So we draw my little x. What two numbers add to 7 and multiply to 6? Hopefully you would agree that it is 6 and 1, I think, right? 6 times 1 gives you 6, and then 6 plus 1 gives you 7. Now, these numbers come in handy, right? So in factored form, we already factored out a negative 2. But the individual now terms are going to be x positive 6, right? My positive 6. And then x positive 1. And the reason I have these square brackets is I need you to understand that there's still a negative 2 on the outside. Now, way back in lesson 1, we talked about how a can impact, or how a can change the value, the shape of the curve. Well, negative, well, now my parabola, right, instead of what looks like a u, it's going to be an n. Now, 2, it's going to be super thin. All right, so I know it's going to be upside down and it's going to be thin. But what are my zeros? What are my x-intercepts? Or what are my roots? Well, I take a look at my individual factors, x plus 6. I set that equal to 0. Hopefully you would realize that the only x value that would make that equal to 0 is negative 6. And then the other one is x plus 1. We set that equal to 0, and hopefully you would realize it's only negative 1. So what do I do with those values? Okay, so I know negative 6, negative 1, and I know the graph is upside down. And it goes something like this. Okay? Now, I want to talk about domain first. Domain is just all x values. Now, I'm not going to waste your time, but hopefully you realize, and I'm going to exaggerate, because the curve actually goes far, far right and left. So when it comes to domain is every x value, because it just keeps going on and on and on. And so what happens is, the way it's written in mathematics is, it looks like this. Okay? Domain, 2 dots, which is colon. Domain is x, okay? It's the x values. And then we do a vertical line, and what that means is it's such that x is everything. Now, how do we write everything? Well, first of all, we draw 2 parallel lines, and then we draw what looks like an R. This says domain x such that x is an element of every real number, and it's normally squiggly lines. Okay? Now, range. Range is the y values. Now, I want you to focus on the y values. You notice the y values go down, down, down. That means there's negative y values. But what's the biggest y value we see here? Well, the biggest y value is hard to see because I didn't graph it really nicely. So I'm going to cheat now. I'm going to use Desmos. I'm going to shut that down. And I'm going to type my equation here. Negative 2x squared minus 14x minus 12. Okay, so take a look. It has an x-intercept of negative 6 and 0, which is what I have over here. It has an intercept of negative 1 and 0, which is what I have here. What is the biggest y value? Well, the biggest y value, hopefully you take a look, the biggest y value looks like 12.5 based on Desmos. But as I scroll down, you can hold your mouse. What's happening to the y values? Well, here it's 9.474. Here is 5.4. And I've got negative values, and it continues on forever and ever. So the biggest y value is 12.5. So instead of writing all the y values, there's something really fast. Now, range. So here's my squiggly bracket, right? Y, range is y, such that the biggest y value, I think we saw, was 12.25. Where's the 12.5? I forget. So let me just close that and just take a quick look. Oh, it's 12.5. So the biggest y value is 12.5. So what we say is y is smaller. Okay? This looks like the letter L. Y is smaller, less than 12.5. And you're done. That's it. Okay? I'm going to pause the video. I want you to sort of spend a moment sort of absorbing that. And then we'll continue on with the other examples in the next video.